Thank you. A lot of fun this morning, sort of diving into things. And we teased a little bit about what we're doing at CISA and why we're doing things at CISA, so I won't belabor that. The important question right now is, should you bother to pay attention or should you look at your phone for the next little bit? We're going to have some in-depth talks later today that will get into the nuts and bolts of SBOMs and a whole bunch of other great security stuff. So what I thought I'd do is sort of help walk through how we're thinking about it using the lens of transparency and how that is currently and going to be an even more important enabler for security in our open source world. So one of the fun buzzwords at the moment is secure by design, and I will confess, I was very skeptical of this idea. Like, as a concept that's been around for a while, and it's always reminded me of the old joke of a balloonist that gets lost. And she wakes up from a nap, she looks around, she doesn't know where she is, she calls down and says, "Hey, can you tell me where I am?" And someone shouts up from the ground, "Yeah, you're lost," which is, it's not wrong, it's just not actionable. And one of the challenges as we think about this idea of secure by design is, first, we got friends. So this is CISA and all of our partner agencies around the world, NCSC UK here, some of the other national cybersecurity centers across Europe, some partners in Asia. So we're all on board with the idea that security should be baked in. I sort of feel we missed a chance to start a bunch of startups saying, security's hard, let's just bolt it on after the fact, because now we're committed to baking it in. But one of the core tenets of this is the idea of radical transparency. So first, the first principle is taking ownership of customer security outcomes. So that tells you a little bit about the initial targeting, right? It's initially targeted to software that's made by someone and sold. So we need to sort of think about what that means in the open source context. But the principle of radical transparency, I think, does really apply, because it's something that I'm going to use the term "we" in the open source, with me and all of my 7 commits can apply. And so first, radical, right? Some of you are of my 90s generation where, that was a term that we used for some reason. And what it means is essentially it's not just a share a few things. It's actually committing to moving forward and exposing ourselves in a meaningful way. So what might that mean? Well, in the proprietary world, that means, Jesus, give us anything, right? It shares some things about what you're doing. But there are, I think, some important pieces that we can work on in the open source world. And one of them is threat modeling. This has been a pretty cool thing to see slowly emerge more broadly in the open source world, is being very explicit about what's my system, what are my risks. Let me diagram how the system flows, identify what the threats are, what is relevant to my system and my users, and then how do we mitigate them? How do we make sure that our mitigations actually did what we wanted them to do, and repeat iteratively? And there's some great tools out there, and there's some amazing people out there that are really sort of bringing this idea, not just in the high-paid consultant to proprietary world, but helping the open source world do it. And then, of course, even if you have your fun threat model, there are going to be flaws. And a core tenet of modern security is, when you have a vulnerability, make sure that people can tell you about it, and then make sure that you can respond quickly. Took us a while, I mentioned during the panel, took us a while to get a handle on this, the fact that, to use a slightly crass example, that when someone tells you that your fly is down, you don't call them a pervert for looking. You thank them and do what you need to do. And so similarly, one of the core things is, hey, when there are vulnerabilities, let's take response. And of course, by the way, large projects and even fairly modest projects can start to take ownership of getting identifiers. Why are identifiers important? Giving a vulnerability an identifier doesn't fix a damn thing, but it helps it fold it into processes and tools. And in fact, our friends at the OpenSF have some great resources devoted to helping open source projects figure out what they can do. Last night I had some great conversations at a bar finding out that our process can be a little better. So one of the things we do at CISA is promote the idea of these numbering authorities. And yeah, we need to do a little better. And we need to understand that feedback loop. So we're hoping to sort of connect from that. But more broadly, why are we caring about this? And by the way, I threw up every possible construction of FOSS and then used a random number identifier to figure out which one I was going to throw on this slide. So apologies if it's not yours. But part of the challenge, as I mentioned, is this stuff is everywhere. And in particular, we are worried about vulnerabilities that will naturally occur. And then, of course, what makes security different from safety or health is that my mattress doesn't stay up all night trying to find new ways to catch on fire. A lot of our baked-in governance models for risk assumes static measurable risk rather than, for those of you who play in theory, rather than a Red Queen hypothesis, which is to say we are in a constant and never-ending arms race where when we fix a thing, our adversaries who have a certain cost threshold will just find a new thing. And so how do we think about this? Well, you can think about it, This is the famous SALSA framework that sort of says here are the risks that will happen at every stage where an attacker can come in and attack your process. If you like thinking about how the secret squirrels think about it, this is actually a fairly dated example right now of where the US government in our serious national security cyber folks have been aware of these supply chain attacks. So we need a lot more visibility at each step of the way. Now, there are some concerns about thinking about the risk, and one of them is, well, if you tell people about your software, aren't you going to help the bad people? And this is one of the most common concerns we get. Usually it comes from people who don't spend a lot of time studying adversary behavior, but from a legitimate perspective, I think it's something we should actually address. And there are a couple of responses. One of them is no one cares that you use libc, Most of the things in your supply chain aren't actually going to be an adversary. 2, guess what? It's open source. Anyone who wants to know what is in a piece of open source software can identify it. And even if it's not, GDRA is free. The famous National Security Agency, the NSA, issued a free reverse engineering tool so that anyone who wants to know what's in pretty much any compiled piece of software that they can get their hands on today can spend a few months learning how to use a tool and then reverse engineer a piece of software. And where we are right now is we have organizations that are using a lot of software and they have no idea what they have. Why? Because the data isn't easy to get. It's not easy to manage. It's not easy to integrate into their existing ways of thinking about their risk. And instead of worrying about a roadmap to the attacker, what we should be doing is giving scalable roadmaps for the defender to understand what they should be focusing on. Now, got some friends here. Some of you are noticing something really strange, which is, Alan, you've been speaking for almost 15 minutes and you haven't said SBOM. Let's talk a little bit SBOM. One of the things that I'm probably the most proud of in my career as a wildly underpaid public servant and truly mediocre failed professor is that I no longer need to spend a lot of time saying, what the hell's an SBOM? So first, just show of hands. Everyone fairly familiar with software bill of materials? Right. It's a fun idea that is ridiculously commonsensical. It is bananas that most software today doesn't have an easy way of figuring out what's inside of it, right? You know more about what's in a biscuit that you buy in a store than what's in the software that runs our organizations, our critical infrastructure, our government systems, our national security systems, right? That lack of visibility is just, to me, crazy, and I think that's one of the reasons that we need to understand that. Why do we need to know, right? Obviously, it's a good line of, we should know what's in things, but why? There are a couple of different buckets we can make. So first is our developers. If anyone is a photographer, could you work with the free stock photo libraries and find a developer that's not a white guy? Because I went looking for a picture, and so we've just got some random screen that basically I think is just showing off the music of whoever's picture this is. But why do we care? Well, across the security world, we just need to know, are we shipping, are we building things that are insecure by design? From the starting point, is there known badness? And one of the fun things about the open source world is, while maybe security has been a niche topic, there has been a long-standing, similarly niche topic, but that is still widely used, which is the licensing compliance world. And this is an area, and I was just over at FOSDEM in some rooms where there are a bunch of people that spend all their time working for large companies saying, hey, what's in this software? Are we allowed to use it? And so on. So part of it is just tracking what you have. Can you say that you have followed anything remotely like secure by design if you don't know what you have as a starting point? And then there are the choosers, right? These are the people who select pieces of software, either for their next downstream open source project, their organization that wants to use upstream, or, dare I say it, maybe buy proprietary software or license something from an organization that gives you that maintenance contract that we heard about today. And again, they need to know what is in their software. They're not going to want to hook it up, or they're going to want to take special extra attention. And there's nothing that says you can't use an out-of-date component. But you need to have, as part of your threat model, a way of thinking about what you're going to do to make sure that you understand the longer-term risk. And then we have our operators, the people who, once I've made the decision, I'm running things, the goal of software is not for it to be secure. The goal of software is to do stuff, right? And so as I'm running this, how do I make sure that I'm able to sort of understand risk? And this is the magical property. It's one of the most annoying buzzwords, but I think it absolutely needs to be part of our lexicon, which is the idea of resilience. Right? There are always going to be new risks, new threats. You know, this software used to be secure, and today it's not. Well, the software is the same, but risks are now out there. We at CISA publish, the world publishes tens of thousands of vulnerabilities a year. The United States National Vulnerability Database has over 30,000 new vulnerabilities each year added to it. That's really a lot. So one of the things we did at CISA is try to shrink that. Let's prioritize the known exploited ones. This makes sense, right? Rather than all risk, let's worry about the ones that we know the bad people are already using. That list, we just celebrated an anniversary, a whole milestone. That's got 1,000 vulnerabilities on it now. Now I think, 1,100, 1,150? So that list is already large. So again, we're starting to understand that we need automation. So let's talk data. Let's have a little conversation about metadata. because that's really where this is driving. Right? The assumption built in, which is the source is the key, I think isn't scaling with us. We simply don't have the ways to think about security and software with automation if all we have is the source. And I think that's one of the core takeaways as we're moving this direction, is understanding what's the metadata that we can focus on, how do we help it scale, how do we help it standardize, and how do we integrate it into our tools. Anything that we're doing in security in 2024 that isn't built in for automation from its initial phase, we're doing it wrong. So let's start with SBOM standards. There are two of them. There's the Linux Foundation's SPDX, there's OWASP's CycloneDX. They're both great. They both do the job. They hate each other. This is one of the hardest parts of my job as sort of the loudest and most annoying SBOM champion with a little bit of, regulatory hammer, is saying, how do we get these two communities to get along? The good news is that I think we're now at a level where everyone else who is aware of SBOM says, yes, we absolutely need to have constant and regular machine interoperability. We have some fun tools coming out. There's a new open source security foundation project that's going to be an automated translator that is built to fit into tools, so it's built to drop into tooling. So that's nice. But one thing is, if anyone ever asks you, hey, which data format should I pick? You know what computers are really good at? JSON, right? Just both is the right answer all the time, forever. I think we're going to talk a little bit later today about VEX. If this isn't on your radar, it's something that should be, because it's the counterpart to a vulnerability advisory, which is that, hey, you know what? Not every advisory that you hear about is going to affect a piece of software or a user of software. And in fact, users of software, what they really care about is when can they not worry about a thing? And VEX is designed to be a tool that enables this idea of saying, I don't need to worry about it. So one shorthand to think about it is an SBOM will turn on your warning dashboard lights. VEX will help you turn them off. This is a famous line from a guy named, oh my God, I've forgotten Carl's last name. Phil Carlton, excuse me. Phil Carlton, one of the, it's ironic that I forgot his name. One of the core devs for Netscape. There are only two hard problems in computer science: cache invalidation and naming things and off by one errors. And it's true. In the entire history of information technology, 40 to 50 years, I would put to you that we have successfully built exactly one global, resilient, robust namespace. And the annual budget of ICANN, which runs DNS, is about $100 million. No one's given me that budget yet. Once I get that budget, we're going to have fun. We're going to build a whole bunch of centralized solutions. But one of the challenges right now is we don't really have a great way of thinking about identity of software. How do I know what this thing is called? And there are a whole bunch of reasons why it's hard. Part of it is just software comes from all sorts of places. If you have a package manager, then you're in pretty good shape. Sorry, if you have a package manager that has local uniqueness, not all package managers do, but if you have a local uniqueness, then it's great. You can just say, go to this package manager, use this identifier, and that gives you pearls. But, of course, vulnerability databases don't use pearls these days. We're starting to get some progress there. This came up a little bit in the future of software keynote today. And this is another one of these embarrassing things that we collectively haven't made progress on, which is end of life and end of support. There isn't an easy way for anyone in a downstream project to figure out whether an upstream project is still viable. Can they use it? We don't even know how to define what end of support means. And so that's something that we're going to be doing at CISA in partnership with, of course, some folks around the world. There's a great OASIS project right now called EOX. It has some really fun people. One of my team members is co-leading that. But essentially, it's one of these areas that starts at the policy level. We need some robust definitions, goes into the technical level. And then I think one of the things we can do is identify a number of easy flags. We're not going to be able to dictate, we shouldn't be planning on dictating to the open source community, this is what you must do. But what we can do is get some convenient buckets so that you can say, I do this, or I do this, or I do this. So, just want to summarize with plugging some of the other work we're doing at CISA. We have an open source software security roadmap. The things among, it includes SBOM, it includes some vulnerability work, it includes promoting OSPOs across the US government. This is an area where Americans really need to learn from our European friends. There are hundreds of OSPOs across the entire European Union. Inside the government, we're working on it. The other area where we desperately need to make progress is understanding prevalence. Old colleague of mine, Frank Nagel, did some work called Open Source Census. But really that was very much the sources of data were around modern applications, enterprise applications, users of commercial scanning tools. We in the government are a lot more worried about what's the open source that the water sector depends on. What's the open source that our election machines use that no one else uses? What does the government use that no one else uses? Because that's where we want to invest our time and effort for safeguarding government systems and critical infrastructure, right? Protecting our citizens. All right, so takeaways. Well, before I get to takeaways, quick plug. If you're interested in SBOM, please join our mailing list. We are having a virtual SBOM-arama on Leap Day. Visit this website and there's lots more information about it. But if you want to know more, one, get on our mailing list, sbom@cisa.dhs.gov. But broadly speaking, transparency is a necessary enabler for almost, I won't say almost all the progress, for a huge amount of the progress we collectively need to make in security. And I don't know of any area where that's more important than the open source community. This is going to be driven by metadata. The easy stuff has already been done. And so the things that are relating are fun challenges. Some of you have spent a lot of time implementing SBOM and realized, oh, not that easy, Alan. We need global coordination, and we need to make sure that the voices that we in the US, in the UK, in Brussels, we work now with Korea and Japan, people around the world, aren't just hearing from the big companies, right? The wonderful people who sponsor this conference, they know how to get in touch with me. They know how to find me, they know how to harass me. What we need at CISA are perspectives from the folks in the open source world. So please reach out to us. I and my colleague Victoria, who you'll be hearing from later today, will be around today and tomorrow. Love to chat about other areas that you're passionate about, or if you're saying, hey, this is solved, go check out this project, or you forgot about this problem, let's work on it together. I think I want to keep us on schedule, so I've got 2 minutes left, according to my watch. Okay. So, one question, my Manchester friend. Oh.
Thanks, Alan. Lots of interesting things. We have a lot of legacy software, so this is really good for things coming with new developments, but how do we get insights to the legacy software? And I know Ghidra will help, but actually that's only a small part.
Yeah, I don't know of anywhere in modern security where we don't just have a giant box for and legacy. Right now, most of the tools that we have are proprietary. They're built on binary analysis models. I think there are a couple of binary analysis projects that are open source, and if someone knows what they are, please shout them out so that we can share with the webcast and things like that. But that's really the only thing you can do if you don't have the source, and you haven't followed Dan Geer's modest proposal of either maintain it or open source, which I think started out as kind of a tongue-in-cheek joke at a Black Hat conference almost a decade ago, and now is just looking better and better as we try to figure out how to get a handle on things.
Thank you. If you want to have a perspective, could you put more pressure on your colleagues at the NVD to go away from CPEs? When I use dependency track, Trivy, Gripe, SNCC on my software, I found completely different vulnerabilities, and I think it has something to do with the naming.
So, yes and no. I think also that just is a function of how scanning tools work and how we need to do a little more alignment and go to the SBOM as a source of truth rather than just a pure scanning tool. But you're exactly right. CISA is a co-sponsor of the NVD. We will be meeting with the whole US government vulnerability ecosystem, including NIST and MITRE, in a month. And this is something we're putting on the agenda. So feel free to write a blog or have some angry tweets and get all your friends to have angry tweets, and we'll bring that as ammunition.
Yeah, Steve Springett wrote a paper about this. I'm a co-signer of this paper.
Wonderful, thanks. And Philippe has been involved. Okay, I think my time's done. We'll be around. Thanks so much for your time.